STEM Hub. Engineering concepts made simple.
So this is a vibration question, just 1 degree of freedom, 1 DOF. So this example states that we have 0.25 kg of mass, and this mass is suspended at a particular spring. So that particular spring has a stiffness of 0.1533 Newton per millimeter. So we are to determine its natural frequency in circles per second. So they said determine its statistical deflection. So we want to determine its deflection in millimeters. So this is just a basic diagram of how it should look like. So this mass would have an effect on this, trying to pull this down. Then your forcing force from the spring will try to reiterate it back. So we know that our angular frequency is 2 pi Fn, which is our frequency. So in this question, we're given our stiffness, right? And we know that from what we have here, Fn equals to Wn over 2 pi. So Wn, which is the angular frequency, is square root of k over m. This was obtained from this general proving, which you are going to see in some of the videos that have also been uploaded. So with this, we have Fn as this. We can change our Wn to be 1 over 2 pi k over m. So this gives us our natural frequency. So 1 over 2 pi, we have what our k is, we have what our m is, which is 1 over 4, which is 0.25 kilogram. So when you put this into this equation, now we obtain 3.94 cycles per second. So as we know, our statistical deflection, we can obtain that from, but do not forget that we have, these are weight. So we have our weight to be mg, weight. This is the mass of the object, and this is the gravity. So we have our weight to be k, then the deflection. This k represents our statistical, our stiffness. Now, one thing to be very careful about is the units that you are given. So if we have 0.153 millimeters, note that the unit is in Newton per millimeter. So we are going to multiply this by our deflection. So whatever deflection we are getting here will be in millimeters. So W over K, which is our weight, which is mg, then divided by the stiffness, then you get 0.019 meters, approximately 15.9 millimeters. So that is for a single degree of freedom, given K and M, you have to obtain, this is the way to obtain the natural frequency and statistical deflection. And the next question, we are going to look at 2 degrees of freedom, where you are given 2K, and how to obtain the equivalent phase. Thank you.